This is the On All Cylinders podcast,
powered by Summit Racing.
Your host for today is Summit Racing's Justin Weideman with special guest Trey McFarland with RaceTec Pistons.
Here we go.
What's going on, guys? It's Justin here, and we're back for another On All Cylinders podcast, and we have a special guest with us today. We have Trey McFarland from RaceTec Pistons. How are you, Trey? Thanks for joining us today.
Excellent. Thanks for having me.
Now, to give you guys a little background on Trey, he is who I like to refer to as the Piston Guru. If I have any questions, he is the guy I call. He knows all the ins and outs of everything that goes in the bore. So, Trey, tell us about your background in this industry, kind of the manufacturing industry, and what you do now at RaceTec.
I've been in the industry since I was 17. Worked at nitrous oxide systems back in the 80s, and moved myself across the country. Worked as a buyer, as a rep, and then have spent the last 20 plus years working with piston manufacturers for the top piston manufacturers in the industry, and currently at RaceTec working with them with some of their larger accounts.
Now, when it comes to pistons, let's just get into it. You have seen the development of the industry, how it used to be. If I needed a piston, it was very limited selection, and I would have to call a piston manufacturer, get 10 or 12 at a time, and then have to wait a substantial amount of time to get them. Now, there's tons of off-the-shelf applications where, I can walk into Summit Racing, get a piston that's about what I need, and we can go there. They cover a lot more broad range, is I guess what I'm trying to say. So tell us a little bit about kind of how that's all changed and what makes that fantastic when you're building a motor.
Yeah, exactly. Back in the day, forged pistons were basically build on demand parts. Pretty much all of them were custom pistons. And then as the industry grew and excelled and matured, the manufacturers started to first identify some custom pistons that they were making over and over again, and decided, well, I'm going to put these popular ones on the shelf because enough guys are calling it, and it helps me with the supply time, lead times. And so that's kind of how it started. And then it continued to evolve. And then today, like you said, there is quite a wide variety of shelf stock pistons. But again, as you said, they cover a little wider range. They're not made for one specific application. So there are often compromises you might need to make. Let's say you wanted a dome that was 12 cc's and what everybody had on the shelf was something around 10 cc's. Okay, so you're going to have 2 cc's less volume, but you can have that piston, in a lot of cases the next day, and it's ready to go off the shelf. No problems with you getting the part and having some sort of communication error, and what got produced was not exactly what you were looking for. There's a bunch of benefits to the shelf stock program. And now, with the variety of pistons that are available, the need for compromise is much less than it was, back in the day when the shelf programs first started.
So say we're going to order a set of pistons for an application. We're building a small block Chevy. Let's talk about what you have to get into to select your piston. So let's start with, I say I have my bore size and I know kind of rod, a couple odds and ends, but what about material selection? Like, does everybody need a crazy forged piston, or is it kind of different, fits for different people?
So one of the most common questions we get is, which alloy should I choose? There are two main alloys that are used for performance forged pistons. There's a 4032 and a 2618 designation. And most of the piston manufacturers use those for different applications. If they're doing it right, they are choosing the alloy for the intended applications environment in which it's going to be working in. Let's say we're building a nice street rod that's going to make 400 horsepower, and I'm going to take it to the cruise nights. I'm going to maybe take it to the track every once in a while and flog on it. But for the most part, just going to be driving around having a real good time. The 4032 alloy is a little more it's a better application or alloy for that application. You've got a guy that's racing. He is going to be looking for, and he's going to be flirting with detonation. Anytime you're racing, actual competition application or any real application where detonation is going to be something that you're going to be coming up against every once in a while. And everybody has the best intentions for not running into detonation, but it happens. And so the 2618 affords you some insurance. It doesn't mean the piston is invincible, but it gives you some added insurance, and it has a little better longevity and durability in terms of detonation. But there are some compromises to that as well. I always get people say, well, 2618 is the best alloy. Well, depends on what it is you're trying to do. If you're running an application where you're running a fairly controlled environment and you aren't flirting with detonation on a regular basis, 4032 alloy has got better durability. It runs a tighter clearance, so it's going to perform a little bit better. It also has a longer longevity and life cycle, given the circumstances, if you're not running into aggressive detonation. 4032 is still a forged alloy piston. It will handle a fair amount of detonation, much more so than the cast pistons that come in, most OE applications. But aggressive detonation, like you'll see under a heavy power type application, boosted or nitrous application, there's a chance there, depending again on how much boost or how much nitrous you're running, that you can surpass what it is a 4032 alloy will handle. And so at that point, you decide to go 2618. But we often get a lot of people saying, I got to have 2618. And then you talk to him about his application, and his understanding of why he wants it is because he wants the best, and he doesn't care what it costs. He's willing to pay for the best. But based upon his application, the actual 4032 is a better alloy for him. So at RaceTec, we try to align the alloy with how the piston was designed to work and what kind of environment it was designed to work in. And in some cases, we've got pistons that are almost identical with both alloys, because the same piston that might work great for a normally aspirated street application also could be a great boosted application for an E85 guy. So again, it's not quite black and white, and the piston manufacturers will always help you make a decision. If you've got any questions, don't ever hesitate to call and ask. But this is a deep subject, and you could go on for a long time on it. But that's the gist of it.
Oh, I love nerding out on this. It's so much fun to learn about. Just a sidebar to touch on one of the things that you talked about is, detonation. You hear a lot of guys, especially with the wonderful internet nowadays, they're like, I make a bunch of crazy power on, you hear people refer to SBE, and that stands for stock bottom end. So that's like a stock, like LS is super, super synonymous for that. There's tons of guys making giant horsepower on stock pistons. A lot has to do with it with the tune of the car, though, and preventing detonation. Going into a better piston material opens up the window of not failing, I should say.
With these two alloys here, a good way to look at it, and if we had a visual, this would be a little better. But if you were to picture both the alloys as they see their first heat cycles, they both soften just a little bit, and then as they go through subsequent heat cycles within their life cycle, they continue to soften. Well, the 4032 alloy, it softens at a very flat plateau type of a plane deal. So its graph would be very flat as it goes down in hardness. Whereas a 2618, it's pretty steady in the way that it softens. And so it starts softening, and it will soften at a faster rate and more steadily. There's not a problem with that as long as you understand what it is you're working with. And so there's kind of some explanation as to why you would choose a 4032 if you weren't building a competition-only application where you are going to be freshening the motor up on a regular cycle. If you're not going to be freshening the motor up on a regular cycle, you don't want to have to be tearing into that engine. Now, not that a 2618 application can't be put on the street and run on the street successfully, but you have to understand what it is you're working with. And if you're making, these guys now running over 1,000 horsepower in motors that go on the street, he wants 2618 because he takes it to the track every other weekend. So that's understandable, but he also wants to drive it. Maybe not a daily driver, but he drives it on the street quite a bit. no problem with that. But you have to understand what you've got, and you have to allow for the fact that at a certain point, that motor is going to need to be freshened up. That piston does, what it will do is the alloy is a little more malleable, and as it goes through heat cycles, it starts moving around a little bit. The ring lands move around, and the skirts can move in a little bit. It's not going to blow up on you, but it will cease to perform at its optimum level. It's just not the same part anymore after it's gone through a number of heat cycles. And that can be subjective too, because if you build a motor and you go and hit it with nitrous 4 times a month, well, yeah, that's some work, and you wanted that extra insurance, but you're not hammering on that piston. So it could still have some pretty good life expectancy, even though you're hitting it every once in a while. Whereas you take it and put it in a pro mod car and start hammering on it the way those guys do, depending on how aggressive you run your stuff, they could need to be freshened up, once every 3 events, if you're that lucky to get that long.
Be realistic with what you're going to doing, and especially when you're, selecting your engine parts. Like, you don't have to buy the craziest stuff for your mild street application or even like your weekend bracket car, just depending on kind of what you're doing. So pick your piston alloy to whatever you're going to be doing. And the folks over at RaceTec are more than happy to help you with that.
Definitely.
So let's talk about selecting our bore size for our piston, because that's an important thing too. The bore size of the actual cylinder is not the same size as the piston. You have a piston to wall clearance. So kind of tell the folks about that, what that means, and why that is such a crucial number.
Yeah, the piston is going to expand at room temperature. It's a certain measured size, and typically we use around 70 degrees as the temperature in which you want to make your measurements on your piston if you are measuring the pistons. And the piston is going to expand. One of the differences between the two alloys, the 4032 has a lower expansion coefficient, so it's going to expand a little less than the 2618. And so you have to allow for that. So what your buddy with the 4032 application can get away with clearance-wise, if you're building a 2618 application, you're going to need to increase your piston to bore clearance. The manufacturers should and do provide parameters to work within, and they generally have a little sheet that kind of talks about how you're going to use the part, and they'll make some adjustments, and they don't change too awful much, probably a thou to a thou and a half difference for one part being used a few different ways, be it a heavy power adder or a pulling vehicle versus a drag vehicle. And so you've got to write the right amount of clearance. We get people that'll say, okay, looser's safer, so I'll just run it loose. Well, that's not necessarily safer. Yes, it's safer in terms of the piston growing to a point where the piston and the bore are trying to occupy the same space. Yes, you're not going to scuff a piston, but running a piston loose, that once it completely expands and gets to full operating temperature, if it's still slopping around in the bore, it's going to beat itself up, and it's not going to perform as well. The rings won't seal up, and obviously it'll make some noise, probably use some oil and some other things. So again, more is not better. You need to have the right amount. And again, piston manufacturers will always help you with some discussions. They've put their recommendations in with the parts based upon the application they designed that part to be used in. But like we talked about earlier, same piston could be used in quite a wide variety of applications. And if you think that you are on the outer edges of those variety of applications, pick up the phone and make a phone call. Don't get yourself into trouble chasing the wrong clearance.
Now, just to kind of talk about the opposite side of that, explain when you don't have enough bore clearance. Tell the folks what a cold seize is.
Typically in an automotive application, it's hard to cold squeeze them because you got too many cylinders. But what you will have is if you've got the clearance too tight and the piston grows more than you've allowed for it, then basically it wiped the skirts, wipe the oil film off of the cylinder bore, and then you've got metal-to-metal contact. And even with a coated piston, pretty quick, you're going to scuff it and gall. And then once that's started, it goes pretty quick. and there's no fixing it. You got to take it back apart. So tighter clearances do perform better as long as you don't run into a situation where they outgrow the piston. Another situation that we run against every once in a while is a guy builds a motor saying he's never going to run nitrous because I'm not a nitrous guy. I'm never going to run nitrous. He builds the motor. It makes good horsepower. He takes it to the track, and instead of running 10 seconds, he's running 11.75. And he's told all his buddies he's going to run 11 seconds. So he calls Summit up and says, I need a nitrous kit. And he goes and puts nitrous kit on this thing. He follows all the instructions, backs off the timing, beefs up the fuel system, gets it all done right, does everything right. But he's put this motor together with a clearance based upon not running a power adder, and takes a motor to the track, and you hit the nitrous onto that thing, and that piston is going to expand much faster than it normally would. And the bore will also expand some as it gets hotter. But if the piston is seeing the heat and the load, it expands more, and then you can scuff it. And again, it could scuff just on the fireland, the land above the top ring. It could scuff there, but then it starts smearing aluminum up and down the bore, and that aluminum gets transferred to the rest of the piston surface that makes contact with the bore, and the whole thing galls and goes bad from there. Yeah, you've got to have enough clearance. At the end of the day, a little bit more clearance is always safer than a little bit than not quite enough.
Kind of the same thing applies to ring gap. A little more will hurt you a lot less than a little less.
Yes, exactly. That's exactly it. And I mean, in a perfect scenario, you would understand exactly how much that piston is going to expand. You'll run the clearance tight, and once that piston is at full operating temperature and the rest of the engine components are full operating temperature, your clearance is pretty tight. It's just basically the oil film.
There's actually really no metal to metal contact. Everything is running with a thin film of oil in between it. And when metal touches, that's bad.
The engine components, especially today's engine components with the materials that are being used in that and the clearances that are being able to be held with the components, a little kiss of metal to metal is not traumatic. But if it happens too frequently, it only takes transferring a little bit of the metal from one component to the other, and then it goes all bad.
So we've talked about alloy selection. We've talked about bore clearance. Really common thing, especially when you're putting an aftermarket camshaft in a vehicle, and even in a lot of stock applications, is valve relief pockets in the top of the piston. One of the things with off-the-shelf pistons a lot of guys do is, you go ahead, you check your piston to valve clearance. If you don't have enough piston to valve clearance, you need to either get a different piston, or sometimes you can modify the pocket slightly, but you need to call before you modify the pocket. So let's talk about that.
Yeah, exactly. There are, as the industry matures, there are a huge variety of cylinder heads available. And even though, let's say we're talking small block Chevy, even though we all call them a 23-degree small block Chevy, there can be valve shifts. The guy could angle mill the thing slightly. There are a number of reasons why the valve pocket in the piston that you purchased may not be exactly what you need, but otherwise the piston is what you need. So it is pretty common, and you should always clay up your pistons. And you basically put some clay in the valve pocket, put the cylinder head on with an old gasket that's already been compressed, and you turn it over, and it'll show you slowly by hand. You turn it over, and it'll show you, it'll compress the clay, and then you can cut it and look at the thickness. And you need to have, there's a couple of different formulas out there, but typically if you can manage around 60 thousandths clearance, then you're safe for about anything that's going on out there. And so if you've got an area that needs to be modified on the piston, it's not the end of the world, but you've got to call the manufacturer and tell, because unless you're willing to cut that piston in half, which then it's useless, you don't know what that cross section is all the way across that valve pocket. In fact, if we get a call on it, Phone Tech has got to go pull the drawing. There are no specs for everywhere. He's going to ask you a series of questions to understand where he's looking at, and then he'll go and get you the information. I can't tell you how many times we get the call where the guy calls up and says, I'm running, this rocker and this much cam and it's got this much duration and this and that. And I need to know how much I can, increase the pocket depth. The guy goes and pulls it and says, looks like based upon the thinnest spot on from the drawing that you can increase the pocket depth by 40,000. And the guy says, oh, yeah, okay. So what if I did 60? The answer has to be that you've got 8 nice ashtrays. It's horrible, but you have no idea how many times we get guys that modify parts before they call, and then they've modified them into something that is not going to work for what they're doing.
So make sure to call and ask questions about your pistons if there's anything you're unsure about or before you modify them. Now, let's talk about wrist pin size and kind of wrist pin location thickness and, why bigger isn't always better necessarily with wrist pins. Because the wrist pin's an important part. That's what connects your piston to your connecting rod and kind of what transfers the motion inside the engine.
Something that a lot of people lose sight of is that the piston and the pin and the connecting rod are a working system. Those are 3 different components that have contact with each other, albeit maybe indirectly between the piston and the rod, but those 3 pieces have got to work together. They are working in close relationship to each other, and if you make an aggressive move on one, that doesn't necessarily benefit the whole combination. And there's a number of mistakes you can make with that, but one of the more popular ones is wrist pin wall thickness. So again, more is better. And so these guys see that the piston pin that comes with their piston set that they're looking at is a 150 wall pin. Oh, well, shoot, I want it to be the strongest. I want a 200 wall pin. Well, what are you, our question is, what are you doing? Why do you think you need to go to a 200 wall pin? And because more is better. Well, not necessarily. The piston moves under load. The small end of the rod moves under load, and the pin moves under load. And if you make that pin so strong and so rigid, it's not fairy dust. It's not magic. The load doesn't go away. It just gets redistributed. So it puts the load to the small end of the rod and the pin bores on the piston. And sometimes that's okay. Sometimes it's not. But if you aren't putting enough load to that piston, if you are putting enough load to that piston to get it deforming around the pin, then you can have some problems. You end up wiping the oil film between the pin and the pin bore of the piston away. And again, as soon as it moves any material from that piston, aluminum gets transferred to the pin, it's all over. It goes away. And something else about pins that a lot of people don't know is the pin in a floating application, which is going to be all of the applications that the performance forged piston people are using for the most part. The pin spins, and you want that pin spinning. It spins, it moves the oil around, it helps with some heat. There's a number of benefits to that pin spinning. If it stops spinning because you have distorted the piston because you put such a strong pin in there, then it wipes that oil film away, and then you get a galling that leads to destroying the piston. The other does also come true, which is not a strong enough piston. The pistons will flex a little bit. They'll even distort in roundness, and ovality. So that's okay if it's doing that. The clearance that we build into the piston and the way the pistons are designed, the pin bores are going to move with it. Again, it's a working system. But if you put too much load on a standard 150 wall type pin, again, same thing. Instead of the pin bores of the piston distorting, the pin distorts to a level that it wipes the oil film away. So if you think there's a question there, if you're in question at all, ask, because those are easy things to adjust. Putting a different pin in, even after you've bought the part. If it comes up after and you do it, we'll swap pins for you. The piston manufacturers want you to have a successful program. They want you to do well.
See, that's something I've never really thought about, and it was a big oversight for me, is even wrist pin material selection. That's something in the future I'm going to pay more attention to. So I even learned something here today. But every time I talk to Trey, I learn something. So it's always so much fun. You've learned all this stuff and you just like to share it with the world.
It's the job of the manufacturers to help educate people and educate them correctly on the components that it is that they're buying from them. There's, again, the internet is a great thing, but it's also an extremely dangerous thing. And I can't tell you how many times I've gotten on a thread searching something for myself, and I see somebody leading some poor guy down the path to destruction. And it's like, oh my gosh, this is going to end badly for this guy.
We don't want to see people not succeed.
For sure. And the manufacturers need to play a part in that. We're actually rebuilding the RaceTec website right now. We're adding a lot of tech information to it that should be helpful to the teams out there so that if they got questions, they might be able to get them answered right off the website. I know not everybody likes making a phone call or has the time to make a phone call. But again, if you get put in a situation and too many people are telling you either too many different things or too many of them are telling you this one thing and you just want to confirm it, call.
Yeah, so you guys heard it here first. If you have any questions about pistons or ordering pistons, call the folks over at RaceTec. And then when you're ready to pick up some RaceTec pistons, call over here to Summit Racing and we'll get you some pistons heading out the door for your ride. Now, there's one other crucial component to kind of this system. We have a wrist pin, we have a piston. Let's talk about rings. That's what seals the party in the combustion chamber and really gives you that transfer of power. So let's talk about ring selection and why that's so important. And, ring selection's broad. You could start at the basis of a gapless ring or a gapped ring, but even ring material design, there's so much to it. So I'll just let you head on out into that one.
Sure. No, rings are very important. The piston manufacturers are proud of the parts that we put out there, but if we don't marry our part with a ring that is comparable to our part in terms of its performance level, it's like showing up to the racetrack on bald tires. It doesn't get you anywhere. You don't need to go out and buy the most expensive double throwdown skinny coated ring for every application, but those options are there because they make a difference, and they do make a difference. And choosing the right ring for your application is key. So there are a lot of materials out there. They act a little differently. Some of them are more friendly than others. Some of them give you some additional insurance, and so when it comes time to selecting your ring, I would always suggest that you use a reputable ring manufacturer. We obviously sell rings, but a lot of guys choose to buy the pistons and source their own rings, and that's fine. Just use your head. And again, ask questions. Call the ring manufacturer. Tell them what you're doing, and tell them what piston you're using and how you're going to use it, and they'll help you understand how much you need to spend and what you need to buy. But some key things or some myths that are out there are ring sizes. For the performance applications nowadays, 1/16, 3/16 rings are pretty much most of the larger rings that are being used in performance forged piston applications, all the way down to some 1 millimeter, 1 millimeter, 2 millimeter as an off-the-shelf type of scenario. Now, there are options for even smaller rings from some of the high-end piston ring sources, and then there are larger rings as well. But for the most part, working within that range is what the majority of the performance public is using. And we get a lot of questions about rings. We use on our shelf parts, we use a lot of 1.5, 3 millimeter ring sets. And we'll get a call every once in a while, the guy saying, well, I put a warranty on my engines. I give the guy 18-month warranty on my engine, and I need it to last. I'm not building pro stock orders. I don't want any small metric ring like a 1.5, 1.53. I want a big 5/64 ring. Well, first, we don't offer pistons for that, although we could modify a piston in most cases to accept a big ring. But the issue with a bigger ring versus the smaller rings are not the issue, but the difference is the smaller the ring gets, the more conformable the ring is. Again, like we were talking earlier, the pistons move around a little bit. Those ring lands move around a little bit. And most people think of ring seal as the face of the ring making contact with the bore, and that's your ring seal. And that is important, But just as important is the flank area of the ring, the bottom part of the ring, making contact with the bottom of the ring groove in the piston. And if the ring groove, the bottom of the ring groove, is moving around and distorting slightly under aggressive loads, then if the ring is less conformable, it'll have a chance to move away from the piston, and then the cylinder pressure goes around the backside of the ring, underneath the ring, and you lose some cylinder pressure. Now, it might be only for a split second, but sometimes it can promote lifting the ring completely off of the ringland, and some other issues that, again, hurt performance. So a more conformable ring seals better. And then when you get down to the oil ring, or the second ring, it'll stay married up against the cylinder bore better if it's calm and working properly, and it will scrape oil better. And then the oil ring also be more conformable, staying in contact with the bore, will pull and evacuate more oil off the cylinder wall, which is important. So thinner rings typically are a better application. Now, there are some applications where a larger ring is something people are looking for. Let's say an aggressive power adder application, especially a competition-only type application. There are some of those motors run in detonation pretty often. And even though they've built a strong enough and a beefy enough piston, it can start distorting the top ring to the point to where it starts losing ring seal. And so some of the people will run a beefier top ring, larger cross-sectional area top ring, so that they can combat some of those aggressive pressure spikes. Detonation is like an explosion. Instead of a rapid burn, it's an explosion, and the pressure spikes, and those spikes, they damage pistons. They also distort rings. And if you're working in an environment where that's going to be happening, a little bit larger, more robust ring is a better application. Again, there's a lot of variables there. There's coatings. Some of the coatings have great adhesion to the rings, a face coating, and are very resilient. Others perform really well in terms of lowering drag and some other things, and resisting scuffing, because the rings can also scuff just like a piston. But you put them in a power adder situation where you're going to be flirting with detonation, and the kind of distortion that the ring's going to see can promote that coating delaminating. So if you start getting into the sizes and stuff, you need to talk to somebody about the rings. Let's make sure that you're getting the right ring for what you're doing.
You're building a fancy high-performance sandwich, and you want to make sure that you build it correctly.
Exactly. And again, the components, they work together. When we're making custom pistons, we'll often ask some questions about the rod that the guy is running. So we understand what that rod's probably going to do under the types of loads that he's talking about putting it under. A great example is a GMLS7 engine with the titanium rod. Pretty cool little titanium rod in that, but put under aggressive load, they move around a little bit more. And that can be a challenge sometimes.
See, this is just so cool, because this is like the stuff that I don't ever really think about when putting an engine together. So just to kind of be able to pick your brain and nerd out on this and kind of learn some things has been really, really helpful. It's just, I don't know, it's neat to me.
Well, good. I'm glad. Again, we want to help. We enjoy the opportunity to help educate the people and put some of the knowledge out there that we gain. A lot of it, we gain it through working with our customers. I learn something every day.
Well, and that's the thing, is talking to the customers. They're your front line in, testing your products.
Oh, that's for sure. Our customers are definitely do some of the wildest things we could ever think of. And we can run a tanker truck full of gas on the dyno and still not learn what we can learn on a handful of tech calls in a week.
That is so funny. I absolutely love that. Trey, this has been a ton of fun. And if you guys are interested in a set of pistons or have questions about pistons before purchasing, make sure to call the folks over at RaceTec or into the Summit Racing customer service line. those folks over there will be able to get you taken care of and get a set of pistons heading to you. Trey, this has been so much fun. Thank you so much for joining us today.
Thanks for having me.
Till next time, this is going to conclude our episode with Trey McFarland from RaceTec Pistons. Until next time, I'm Justin with Summit Racing. Thanks again, Trey, and we'll see you guys later.
This has been the On All Cylinders podcast.
Powered by Summit Racing.
Check out new episodes coming soon at OnAllCylinders.com.
OnAllCylinders.com.
Thanks for listening.
See you next time.